overview of steel structures. We know steel structures will have less weightage. So what are the important specifications that we have to remember, and what are some important bits that we have to cover in steel structures? Without consuming much time, I will be explaining this. Okay, whatever we have to remember the specifications instead of showing in the video, because there are so many specifications that we have to simply by heart. So I have loaded that into a PDF and I gave a link in the description, so you can download that. What are the specifications you have to remember and you can by heart. So during the lecture I will be explaining everything what is there in the PDF and what we have to remember. So first, coming to introduction, similar to introduction of concrete structures, here also we will have factor of safety for the materials. Okay, but here they are not called factor of safety, they are called partial safety factors, because we don't take the full value, we take only part value, that is 1.25, 1.1, like this. Okay, so what are that values for welding, for bolts, for different cases, you can see in the PDF. And second one, similar to load combinations in RCC, load combinations will be there in steel structures also, but here we have extra crane load and accidental load also, because crane load, that is moving loads, also will be there in steel structures, as we know. So the load factors, whatever we are multiplying the partial load factors, you can see from the table that is there in the PDF introduction chapter. Apart from that, in introduction chapter you also have to remember some physical characteristics. What is the density of the steel, what is the Poisson's ratio of steel. So like this, what are the physical parameters that we have to remember are also there in the PDF. So just by heart that values. And another thing, slenderness ratio of a structural member in different situations. Okay, so these four are very important things. And what are the values you have to by heart, I have given in the PDF directly. So by heart those values. Whatever I have mentioned in the PDF, everything is very important. Apart from that, we know that unlike concrete, steel cannot be prepared in the site. So steel will be prepared as a rolled section, hot rolled section. So we have a separate steel table code, we know that for that, for the list of sections that is available. In concrete, we will be designing a cross section and we will be placing the steel formwork, concreting everything according to our design. But in steel, you need not design anything. Whatever the sections that are available in the market, directly will purchase and install that. Okay, that is why you will not have much design in steel structures, unlike RCC. So just you have to select which section will suit our purpose, purchase that section and install in our site. During installation, what you have to take care, that installation procedure, you have to connect them with using rivets, bolts or welding. So how we do that, we'll see in connections. In introduction, I have given the list of rolled section, what is ISMB, what is ISHB. So that abbreviations are also very important. So what are the abbreviations that you have to remember also, I have given in the PDF, go through that. Okay, so that are the important things in introduction. Okay, next, coming to connections, we have bolted and welded connections. So in the cross section of bolt, this is head of the bolt, this is called shank portion, and you will have a thread portion. So this area will be pi by 4 into d square, and this area will be 0.78 pi by 4 d square, this thread area. Okay, so here for a bolt of diameter d, how much bolt hole has to be introduced in the plate, that value is also very important. In working stress method, we just used to add plus 1.5 or plus 2 depending on the size previously in working stress. But now you have to you have a fixed values based on the diameter, that is as per the IS 800 2007. So go through that values, by heart that values given in the PDF. Okay, so apart from the bolt hole diameter, what are the other specifications that we have to remember in bolted connections, we will see. So So suppose if one plate is connected to other plate like this is called lap joint. I'll show you the front view. This is top view, means two plates. This plate is ending here, and there will be another plate. Okay, so if you see from the top view, you cannot see this, right? So it is shaded like this. Okay, you can see this, you can see this, you can see this, but you cannot see this. So it is shaded like this. So here you have bolt, here you have bolt, here also you have bolt. Okay, so this is the length of the plate. If I see from the top view, here I have again 1 2 3 1 2 3 3 bolts. So here I have 3 bolts, 3 bolts, 3 bolts. Total in the top view I can see 9 bolts. Okay, so this is called lap joint. Okay, so in the lap joint the problem is you will have a eccentricity in the lap joint. Okay, to avoid this eccentricity we can use something called butt joint also. So butt joint will always have a cover plate. Butt joint will look like this. Okay, so for a butt joint you can use cover plate. Okay, so this is called double cover butt. If you use it on only one side, then it is single cover. But single cover again will have eccentricity, so better to use a double cover to avoid the eccentricity in loading. Okay, so because of this load, you can see the bolt is getting sheared, and also the load is transferred through bearing. Okay, so the exact transfer, to tell you exactly what happens, it takes some time, but I can say that more generally the bolts will be subjected to shear and also bearing. Okay, so among this, what is the minimum strength? We take the strength of bolt. Formulas are not important. Okay, we will forget about the formulas, but you have to know that in that you will be taking the minimum value. Okay, next, apart from this regular bolts, we have something called high strength friction grip bolts. Okay, in normal bolts the load will be transferred through shear and bearing, but in HSFG bolts the load will be transferred because of friction. Okay, and in tension members, when they are connected through HSFG bolts, it is subjected to a different force called prying force. Okay, formula is very difficult to remember, but just remember that prying forces are tensile forces because of HSFG bolts. Okay, that is one important bit. When we see in the connection, here this is the length of the plate, and this is perpendicular to the length. So you will have force generally along the length of the plate in this tension member. When this is subjected to like this, generally at the end, suppose if this is the plate, what we call this plate, we call this as end. At this end, how much distance we have? This is called end distance. So along the length, in the end, how much distance we have is called end distance. Okay, that end distance, minimum end distance should be there for a bolt, but specifications of end distance are not much important, but still we should have a minimum end distance. Suppose if I give you a plate and ask you to invert a bolt, you will not insert. So suppose if I give you a plate and ask you to insert a bolt, you will never insert a bolt at the end, right? Always you will try to place somewhere here, right? So this is called end distance. In the end, how much distance we have, that is called end distance. Similarly, perpendicular to the load we will have edge distance. This is measured from center. So this is called edge distance. This is very important. The specifications of minimum edge distance are important. The specifications has been mentioned in the PDF. So you can read what is edge distance and what is the minimum edge distance required. Okay. Apart from that, this is called pitch. I told you in the end it is called end distance. In the end, how much distance we have, that is called end distance. In the middle, whatever the distance we have, this is called pitch, and this is called gauge. Okay, so along the load is called pitch, perpendicular to the load is called gauge, along the load at the end distance, perpendicular to the load at the edge is called edge distance. Okay, so edge distance will be there throughout the edge. Throughout the edge you will have edge distance, but end distance will be there at the end, like this. So these are end distance at the end of the plate, edge distance perpendicular. Okay, so here specifications of edge distance, minimum value of pitch are very important. So what you have to remember in connection I have given in the PDF, just have a look. Okay, apart from that, if there is a staggered pitch, staggered means like this. Okay, so in a staggered pitch, how to calculate the net area? AN is given by B minus ND plus sigma P square by 4G into T. This is the formula to calculate the net area. I have mentioned in the PDF also. So what does this means? So I have given a sigma here, right? What does this mean is, in this plate, to find the effective area, this much bolt hole I have introduced. How much bolt hole is required for a particular dia of bolt? You can see from the table. So what is the effective area that is resisting tension? It is B. Suppose if this is B, B minus ND naught into what is the thickness. So this much breadth into thickness is only resisting my T value. Suppose if it is like this, I should not take like this. I should take like this. So this length into breadth. What is this length? This length, you can see this is inclined, right? This inclined length is nothing but total B value plus P square by 4G. So you have one slope, so slightly the value will be more than B value, so plus P square by 4G. Another slope, slightly more, another P square by 4G. So suppose if I have 5 rivets, let us take like this, whatever. You have to join from the top to the bottom like this. So P square by 4G, P square by 4G, P square by 4G. So from the top you have to join all the rivets, and then you have to calculate P1 square by 4G, P2 square by 4G, P3 square by 4G. As the load is along like this, I have taken pitch like this and gauge like this. If my load is like this, I will call this as pitch and this as gauge. Okay. So these are some of important formulas, and what are all the specifications you have to remember in connections. I have given in the PDF, by heart those. Okay. So next, coming to welded connections. In welded connections, we have two types of weld, fillet weld and butt weld. So formulas are not so important, but what are the specifications we have to remember? I have given the list directly by heart, that will be sufficient. Whatever the connections till now I have shown you, they are concentric and eccentric connections. In lap joint we have some eccentricity. You will have something called bracket connections also, okay, where you will have large amount of eccentricity. There are again two types. This is called bracket plate connected to the column. Example is, you can see a electrical pole, you will have one bracket and then you will have load from the wire. That is called bracket connected to the column. Okay. To apply the load, you will connect something called bracket plate. Okay. There are several examples for this. This case is called load lying within the plane case, and this case is called load lying out of the plane. Okay. So in this case the bolts are subjected to shear and also torsion. In this case the bolts are subjected to shear and also bending. If you have observed my shortcut for identifying bending and torsion, you can easily identify why this is torsion and why this is bending. This is load lying within the plane, this is load lying out of the plane. Okay. So just to see how to find the resultant forces also in these both cases. Coming to welding, in welding this is not at all important, this case. Okay, but in bolts, which bolt is subjected to maximum torsion, that cases are important. So if they ask which bolt is subjected to maximum force in this case, then your answer will be this one. Okay, so what I did not give any numbers. So suppose if I take 1, 2, 3, 4, bolt 1 will be subjected to maximum amount of force. You may get a question like this, okay. So if you identify the force directions, then you will know why bolt 1 is subjected to maximum amount of force, okay. So we don't have much time to explain this, okay. So that are the important things that we have to see from the connections chapter in bolted connections and welded connections. Coming to tension members, okay. In tension members, we have 3 types of failure, that is gross yielding, net rupture, block shear. These 3 names of the failures is very important. Formulas may not be asked. Gross yielding means the entire plate will yield like this. You know what is yielding? It's similar to plastic failure. It will have huge amount of strain before failure. This is called gross yielding. What is a net rupture failure? Second type of failure is net rupture failure or tearing failure. What is this tearing failure means? Previously in RCC we have seen there is a ductile failure and there is a brittle failure. Brittle failure means how if you break a chalk piece how it fails, that is brittle failure. So we know about brittle failure, we know about ductile failure, but there is something called tearing failure. What is this tearing failure? If I give a paper, if you tear that is called tearing failure. So similar to that, a tension member plate also will fail similar to tear. That tear will not start from the end, it will start from the center of the bolt. Because of stress concentrations, first you will get the tearing here and then it extends till the edge like this. Previously gross yielding, whatever I told, it can come here. This is called gross yielding. This is called tearing or net rupture, where from here first the failure start and the plate will get teared like this. Okay, this is called net rupture. And there is something called block shear failure also. It will take some time to show how the block shear failure will happen. Formulas are not important, but in the procedure, among these 3, whatever the case which gets the minimum amount of load, that is taken as tensile strength of the connection, and efficiency of the connection is given by strength, that is minimum of the 3 cases. Strength of the connection divided by strength of solid plate into 100. Okay, solid plate means here without any bolts, what is the strength you have here? So compared to, as you have inserted a hole, the strength here will reduce, definitely it will reduce. So compared to the solid section, how much strength your connection have is the efficiency of the joint. If you are able to get the strength exactly what you have before inserting the hole, that is 100% efficiency. The connection has 100% efficiencies. Generally, most of the time, the failure will happen at the connection place only. You cannot get the connection strength exactly equal to plate strength. That is the reason every time your connection only will fail. So compared to the solid plate, what is the strength of connection? That is called as efficiency of the connection of tension member. Okay, so that are the important things we have to remember in tension. We don't get much question in tension members. Next, coming to compression members. Design of compression members is a very tough task, and definitely you cannot get any questions from design, but you have to see what are the effective length with respect to different boundary conditions. I have mentioned that in PDF, you can watch that. Next thing is column base. What is this column base means? In RCC we have footings. Below the column you will have footing, but in steel structures below the column you will have bases, column bases. Below the electrical pole, if you see, you will have concrete. That concrete will help to resist the steel to avoid corrosion without inserting into the soil, and also it reduces the stress. If you have seen the electrical poles, sometimes they will be embedding into the concrete, okay, and then you will have soil. Okay, so if you have directly concrete, this is called slab base. And sometimes what happens, if you have observed, there will be connecting a plate like this. So you will have one plate like this. You will have one plate like this which is connected using angles like this, and you will have bolts like this. Okay, this is called gusset base. Okay. Apart from this, we have something called grillage base for very low bearing capacity. In footings, what you will have strip footing, mat footing. Similarly, here also you will have grillage foundation when the bearing capacity is very less. Okay. So here what you have to know is, in slab base, 100% load transfer through bearing, and the bearing capacity of the concrete is 0.45 FCK. And in gusset base, this is called gusset base, previous one was slab base. In gusset base, partially the load is transferred through bearing, and partially the load is transferred through gusset plates. What is this transfer of bearing? What is this transfer through gusset? If the students have no idea, I will tell you one practical example to understand this. Suppose if I am standing here, my entire load will go into this floor because of bearing. Okay, there will be no concept of gusset plate here. I will come to that. Suppose if my legs are paining or the floor is unable to take the load, then what I will do? I will try to lean to this board so that some load will not go through my legs, some load will go into the board and then go to the floor. Okay, so I am reducing the amount of load that is going through bearing and transferring through gusset. Okay, so in slab base what happens, 100% load will go through bearing. In gusset base, partially it will go to gusset and partially it will go through slab base. Okay, so that is the difference between slab base and gusset base. If the bearing capacity is very less or the load is very high, then you have to improve the base by something called grillage foundation. Okay, so that is quite difficult to explain now. You have to understand that there is something called grillage base, which is similar to mat foundation which we see in RCC structures. Okay, so that are the things you have to know about column bases. Next, coming to built up columns. Sometimes a single section will not be sufficient to construct a column. Then you will be using group of section connected by using lacings or battens to form a section. In railway stations and in many places you might have seen there will be 4 places connected using lacings or battens. Okay, so like this you will be seeing lacings or you may be seeing battens. These are called lacings, these are called battens. Okay. Compared to battens, lacings are more preferred. What are the things that you have to remember in lacings and battens? I have listed. Just by heart that values, that will be sufficient for built up columns. Okay, so that is about compression members. Okay, so in design, just remember what is the effective length. Okay, remaining things are not important. In column base, just the basics, what is slab base, what is gusset base, formulas are not important. And in built up column, what is specifications important in lacings and battens. That's all. Okay, next, coming to beams. In RCC, how we have designed beams? First we designed for bending, next we have designed for shear. Similarly here also, for bending, first we have to know whether it is laterally restrained or unrestrained beam. Okay, so the design is quite complicated, it involves a lot of formulas. Just I will tell you what is laterally restrained and unrestrained beam. Suppose if you have a beam like this, okay, what is laterally restrained means, if the beam is laterally not stable, then it will overturn like this. Because of this, it causes something called lateral torsional buckling. Okay, it takes some time to explain that. So just you have to understand that laterally it is not, this is called longitudinal direction, this is called lateral direction. So this beam is laterally not stable. So we place some restraint so that it is restrained so that it will have lateral stability. So we reduce the length, effective length, by placing some restraint regularly like this. So these are called laterally restrained beam by placing the restraints at regular intervals by reducing the effective length. Even in serviceability of RCC also I explained the concept of lateral stability. Therefore a cantilever L should be less than 25B or 100B square by D, and for simply supported L should be less than 60B or 250B square by D, that is lateral stability, whatever I said. Here also similarly, we'll have laterally restrained and unrestrained beam. The design is quite different for laterally restrained and laterally unrestrained. This is about important things in bending, okay. Formulas are not so important. Just to understand what is laterally restrained and unrestrained, I explained this. Next, coming to shear. There, how we design shear for RCC. First we will see whether our tau v is less than tau c. Then you will see if tau v is greater than tau c. If tau v is less than tau c, we use minimum shear reinforcement. If tau v is greater than tau c, then we use design shear reinforcement. Here also, how the shear load is defined means, for the section whatever you have taken, if the shear load is less than 0.6 times of design shear, then it is called a low shear load and you will have a different design. If the shear load is greater than 0.6 times of its strength, then it is called high shear load and the design is different, okay. So in this way, to design for bending, you have to know whether it is laterally restrained or unrestrained beam. To design for shear, you have to know whether the load is high shear load or low shear load, okay. So that is the basic things in beam design. Next, coming to class of the beam, you have to know something called class of the beam. The beams are classified into 4 classes depending on the rotating capacity. To understand this rotating capacity, you have to know something called plastic theory, okay. Here I cannot explain the theory. All the beams are divided into 4 categories, class 1, class 2, class 3, class 4. So what are that definitions? I have loaded in the PDF, you can read that. So depending on the type of section, you will have rotating capacity for the beam. Based on that, you will have some factors which affect the design of beam. Till that I can say, definitely read what are the classes of the beams that we have, okay. So what is the plastic section, what is compact section, what is semi-compact section, what is slender section, okay. Like this you have 4 types of sections for beam. So read all those sections. And plastic theory, this is very important among the entire steel structures. Most important is plastic theory. Plastic theory is not about important specifications or important formulas. It is a method which has to be practiced with a number of examples, okay. Students who are leaving plastic theory, I have given you what are the important shape factors that we have to remember and what are the important collapse load. Minimum whatever you can remember from plastic theory I have given. But if you can prepare, you have to prepare both using static method and a kinematic method, how to calculate the collapse load and also how to calculate the shape factors, okay. So I advise you to prepare complete plastic theory. If it is not possible, if you want to leave steel structures, at least what you can remember I have given in the PDF, just remember that and you can leave the remaining things, okay. Next, girders. Many students will have doubt, what is this girder and how it is different from beam. To understand this, I will tell you with respect to RCC and also on practical examples to understand what is this girder. First I will tell you with respect to RCC. Okay, in RCC we have something called deep beams. You did not see the design of deep beams because it is not there within your syllabus. You will get the design of deep beams in MTech. Okay, so that is the reason you do not know exactly what is deep beam. Deep beam design is quite complicated compared to the normal beam design what you are seeing. Okay, so that is with respect to RCC. I am differentiating normal beam with the deep beam. Now I will tell you on practical example. Suppose if I give a wooden stick, a small section of wooden piece, then you will call it as stick. Suppose if I give a large section, then we call it as wooden log. We call this as stick. We call this as log. Okay, we don't call this as stick because its size is very heavy. Okay, I hope you are able to correlate. This is, you don't call this as stick or you don't call this as log. You are calling this with respect to the cross section dimension, right? Similarly, after a particular section, whatever the rolled section beams we have, after that particular depth, whatever the depth we have, we cannot prepare in rolled sections. We have to manufacture it by connecting different plates. like you will have web plate and we will have flange plate. This is not rolled section. Okay, we will connect different plates to form these I sections. So as because of heavy sections, they are called girders. Okay, so if I call this as stick, how you will feel? Similarly, if I call this as beam, similarly you have to feel, as you have not habituated to girder word, you feel this as different, but the action is just similar to beams. Because of its heavy section, it should be joined with some stiffness. What we can say, suppose if a person will have more height, he cannot stand very easily. You can see, you cannot stand very easily. He will stand like this because he needs some stiffness. His stiffness is very less because of higher length. Okay, to understand this, I will tell you one practical example also. If you have observed thin members sitting on the chair, they cannot sit straight like this. Either they will lean or they will place one leg over the other. Why they do that means, so suppose if they are sitting like this, okay, so this is the leg and this is the floor. Okay, so as they are sitting on the chair, mostly they are getting the load only from the leg, and their leg weight will be very less because they are very thin. So they will not get much reaction into the leg, so they will feel that the leg is almost hanging. You cannot get much reaction from the floor because it is not stiff. So what they will do, they will press their leg with hands like this. They will lean and press their legs with hand to sit properly, or what they will do, they will place one leg over the other to get the enough compression, so that you will get some reaction from the floor to be stable. If there is no reaction from the floor, this will be similar to hanging and you cannot place the legs stable. So that is the reason they will place one leg over the other. If you see the people who are hefty, then definitely they can sit like this because they will get enough reactions to sit comfortable and stable. Okay, so I hope you understood the requirement of this stiffness. So here I am getting stiffness because of compression. So similarly, for plate girders also we will have bearing stiffeners, intermediate stiffeners, different types of stiffeners. In which cases we have to use which stiffeners, I have given the list. Just go through that list. That will be sufficient. And gantry girder and gantry girders will be used in industries to move heavy materials. Okay, this is not important with respect to state gauge jobs at least. And you can also leave roof trusses. This is also not much important coming to state gauge jobs. Okay. So that is the overview about steel structures. On August 15th, I will be releasing a video explaining the complete details of the website and its future plans, how I am going to proceed. On August 15th, you can see what you are going to get in the website, how the website will look. Every detail I will mention in the website on August 15th, and the website will be opened on September 15th, as I am saying from the beginning. Thanks for watching.